compiler, their standard library, but for some reason, their convention, in another operating system, the convention for their successful return value of executing, a program is different. Let's say it's not 0, but it's 100. Then you recompile your code in that system, and it works as before. If you have this hard-coded 0 here, you take this code to another system, and there 0 is no longer their value for the successful completion. It corresponds to an error, and your code no longer works the way it was supposed to. So that's why I feel this exit success is important. And like I said, if you feel differently, then it's perfectly fine. But at the minimum, you should be able to read the code that follows the convention that I'm trying to stick to, right? So it's not like you look at this exit success and you have no idea what it means, right? You have to know all the different ways to run the code and all the different sides of any holy war that we will already talked about. And if you need to look up their other values, you can easily do that. Here they are. So there is exit success, there's exit failure. Okay, so you can certainly do that. Okay, thank you, Ji, for answering this question. You don't have to define exit success at the top because it's defined in this std lead. Okay. All right, and then here's our is defining I outside the function always required. If I do that in for loop, is that considered an error? Okay, we'll get to that question. It's actually in the slides. Okay, so the reverse, our first attempt at the reverse function. So the idea is that it should be a program that takes an argument through the command line and treats that argument as a string and reverses that string. So the important thing to remember about strings in C is that there are no strings in C. So plain old C has no support for strings. There's no such thing as a string. However, the plain old C offers us what is known as C strings, which are just arrays of characters that end with a null character. This \0 is called a null terminator or null character. So that means that any sequence of characters that you have in the array must be terminated with this \0 or null terminator in order for C functions that deal with C strings to understand that the string ends here. So this null terminator is used as a delimiter because any function that deals with strings in C, it will take a pointer to the beginning of the string. But how does it know where the string ends? The only way it knows is by reaching this null termination character. That's how it knows that the string ends here. If you skip this null termination character, then depending on their specific memory contents, your string may just continue printing with whatever values of memory there are in their memory locations after this last O. And eventually it will probably hit a 0 character, and that's where it would stop, or it may just go over their allowed memory segment and result in segfault. So in any case, it is dangerous. It is not it is not encouraged at all. So you should have a 0, this null terminator at the end of all your strings. The terminator included in the length of the string? No, the length of the string is the number of characters in it. However, when you reserve the memory for this C string, you have to account for this null termination character, right? So, here we, for this, you know, so if we were to reserve memory for just this hello, right, which is 5 characters, we would have to actually have an array of 6 characters because we need, an additional element of the array to physically store that zero, this zero character, this null terminator character. Hey, that's a great observation. I didn't account for it for the lab, and it still worked. So it may work. But that doesn't mean that your code is correct. It means you just got lucky because probably the machine on which you were running this code, initially had all their memory contents zeroed, and then when you ran your program, the operating system loaded your program. So it loaded this HELLO or whatever that string was in the memory, but the rest of the memory was left untouched, which means that automatically there was this zero here. But you just got lucky, right? On another machine, or even next time you run this program, you may not get as lucky. So you need to make sure that you write your code that follows the rules. And it is particularly so, like you run your code locally and it seems to be running fine, and then you submit your code on Submit and you get like a seg fault or something, and you're like, how is that possible? Is Submit broken? And the answer is usually no. We all know Submit can have bugs, but more likely than not, it's not the Submit which is broken, but it's you writing the code that does not follow all the rules. And when you run locally, for some reason you just get lucky. And when you submit on Submit, you don't get as lucky. And Submit gives you 0. Oh, I admitted Submit is buggy. Yeah, sure. We all know Submit is buggy. But you know what? All software is buggy. If you can name me one software that is guaranteed to be not buggy, non-trivial, of course. I'm not talking about Hello World, but any software that you can guarantee and prove that is not buggy. I would I would be really glad. Okay. So that's the reverse, and the algorithm itself is pretty straightforward. So we, since we need to reverse the string, so we need to, something to hold that new resultant string. So that's why we, we define this array of characters, and in this case, we don't want to mess with dynamic memory allocation, and that's why we specify the maximum size of the array. So what it means is this program will work correctly with any strings that are less than or equal this max size, considering the one element that is used for the null terminator. But it will not work, for strings that are longer, right? So here, obviously, it's not very, realistic, right? Because we just make this number up, right? We don't have any good justification for why it's 1,000 and not 500 or not 10,000, right? But this is just to demonstrate that in cases when you have a natural upper limit and you are fine with possibly wasting some of that space, right? If you only have to deal with small strings and you would still reserve 1,000 characters, right? You would still have 1,000 elements in this character array. But in cases when you can do that, you can simplify your code by avoiding dynamic memory allocation. So here we have just a statically allocated character array, and we collect our reversed string in this character array. Then we need to make sure that we put our null terminator, and that's it. The last step is we copy this inverted or reversed string back to the original array S. okay, which previously held the original string. So we overwrite the original string, and that's pretty much it. Can you define a max that would require more memory addresses than the computer has memory? Yes, you can. So the amount of heap is not guaranteed. It depends on the machine on which you're running. It depends on other programs that are running. So you can totally try to request more memory than is available. But note that and that of course your program is not going to do, and you will only learn about that at runtime. So, but it's the same problem with a dynamic memory allocation and heap, right? So even if here it's statically allocated, right? But if we are talking about dynamic allocation, then the same thing can happen, right? No one is guaranteed a particular amount of dynamic memory. So you call your malloc, and it may return null, meaning that their memory allocation was not successful. Should we check to make sure that len is less than max? For that we need to actually look at the code and see where our s is coming from, right? So this s for reverse is just an argument, and here it is coming from argv, and argv is coming from the operating system. So the real question is it possible for a particular operating system? So operating systems have their own limitations on their maximum size of command line arguments. It's similarly just some kind of magic number, like 256 is pretty common especially in older operating systems, right? So it's just another magic number, and yes, if you know that this magic number for an operating system is larger than 1000, then yes, you should check if if their size of your buffer, this buff would be sufficient. Because if it's not going to sufficient, right, this len is going to be the real length of your input string, and then you would overrun your buffer, right? So if the len happens to be 2000 and your buff is only 1000, then your code will be just overrunning their their this buff array, and of course you're likely to get a seg fault. If a type has a long name, you can rename that with typedef, so you don't have to type all that. Yes, so this is regarding this typedef, right? It stands for type definition, and that's exactly what it is, right? You want to give a name to a type. You want to define your own user type, and then you can use that user type as examples of this reverse program shows, like right here, a big string. Right, so you could have instead of writing big string, you could have written char max in brackets here when you're defining buff. It would be the same thing, but of course it's advantageous to define your own types, especially if you plan on defining more than one variable, if you plan on reusing this type. So regarding argv values, so here's their here's their comment that shows how command line arguments are, and so this argv array is an array of character arrays. So you see it's an array of what we call C strings, and the first element in this array is the name of the program itself, is the name of the executable. And that are the actual command line arguments. So hello would be the first command line argument in our example. Can you call your type string instead of big string, or is string a keyword in C? No, string is not a keyword in C. So string is there are strings in C++, as you all know, but there are no strings in C. So you can call this. So this can be anything you like. Big character thing. Whatever. It's up to you. Okay, so that's the reverse C example with no dynamic memory location, just static memory location, as we can see here. And of course, it's not a real good example. Well, it's not, very sophisticated. It has its limitations, because what if we don't have a good upper bound for this, max size of the string? Yeah, there are no strings in C. Yeah, believe it or not. Yeah, C. So when we say C strings, right, it's really not a string. It's a misnomer, right? It's just a convenient colloquial name when we say C string, meaning it's a character array with this null termination character that indicates the end of the string, right? But there are no strings. So to contrast with C++, where a string is really a data structure on its own, that you don't have to make assumptions about null termination. You don't even have to make assumptions about whether that string in C++ is stored in contiguous memory locations, because it may not, depending on their C++ standard. There may not be even guarantee that all your characters are stored in consecutive memory locations. In C, it is guaranteed, right? So it is guaranteed that all elements of this array are stored in consecutive memory locations. So that opens the door to using pointer arithmetic with with arrays. Yeah, string H is a lie, right? Because it just contains definitions of certain functions that are capable of working with C strings, and like strlen, strcopy, and the like. Does terminating the string free up the memory that it is not being used? No. So and you can actually make an example where you and play with string literals, where you actually embed a zero, this null termination, a character with code 0, somewhere in the middle of the string. So if you allocated a certain amount of memory, here it's statically allocated, exactly 1,000 characters. So this whole buff is 1,000 characters always, unless you change this value. If you dynamically allocated memory, it's still the same story. However many bytes you initially allocated, unless you reallocate, it's gonna occupy the same amount of memory. Even if your string is just one character, so H, and then your null terminator, the amount of memory allocated, whether statically or dynamically, is going to be the same. It's going to be full 1,000 this case, or however many bytes you requested when you did your memory allocation. Oh, you missed strings. And C++, yeah, C++ comes with certain convenient things, but it is also more complicated. Just think about all their inheritance and virtual functions and all that stuff, which is just not a problem at all with C. Okay, so that's that, and this is our reverse. Okay, and then the you want to take is, well, can we make our program a little bit more sophisticated so that we we don't have to make up those artificial limits, that we can say, well, whatever the length of their input string is, we're just gonna allocate their memory for this temporary buffer, for that exact same, so that we don't have to do this, to come up we can. And the other way we do that is by allocating memory. But before we allocate memory, let's talk about pointers. All right, so I'm sure you are familiar with pointers from C++, and ampersands and stars, and it can get very it can be a lot of fun when you have multiple stars and parentheses and all that. So hopefully you remember all that fun, and we're gonna we're gonna get all that fun here with C as well. All right, exactly the same in C as they are in C++. One thing to reiterate, so there's no references in C, so this is not valid C code as we discussed last time. But to pass a value, so what want to get this done in C? Well, we can still pass by reference, but we would use pointers for that. So we would declare a variable, we would declare a parameter as int star, saying that it's a pointer to an integer, and then when we call foo, we would supply an address of the variable. So if y is an integer, then ampersand y is the address of that variable. Right? So we take the address of variable y, we pass it to foo as a pointer. So anytime we want to access the value that is pointed to by this pointer, we have to dereference. So hence this star x, right? So because we want to multiply values, not pointers, right? So here we are with all those stars. Okay, what if we make two pointers point at each other? So a pointer is just an address. You can, you can make it point anywhere you like. Okay, so can we just do a foo of y? No, you can't. And then foo with int of x, yes, you can. But then, let's do this. Okay, so we can totally do this. And then the return value would be computed as the value of x times the value of x, and it will be returned. Okay, so is it going to work the same way? Yes, no? Yes. In this particular case, it would work the same way. However, what we wouldn't be able to achieve, what if we wanted to change y inside foo? Okay, so the way our code is written right now, x is independent from y. X has the same value, right? When we invoke foo with y, x gets the same value as y. So we compute this expression, we return it through this, return value of foo, and y is not changed, and everything works. However, what if we wanted our foo to change y? If we change x, if we have some kind of assignment here, right? It would not affect y because x is a different variable that contains a copy of y. So that's where pointers become really handy. Okay, so for x, all right, that is referencing this as y. This is a reference. This is a reference to y because x is a pointer that points to y, and this way you would be able to update the value of y from inside foo. And that's why we say pass by reference, right? Because then you have a reference and you can alter the variable that is being referenced. Wait, I thought we couldn't do references in C. Well, we couldn't do references because in C++, this is what is called a reference. Okay, so in C, we only have pointers, but with pointers, we can reference variables, right? So it's reference in a colloquial sense, not in not in the sense of the syntax of the language, right? So here my x is a pointer to y, right? So x contains the same address as it contains the address of variable y, right? Because we took the address here and we put it in x when we invoked our foo. And that's why we can say that we were able to pass y by reference to foo, right? Yes, it's not using references, it's using pointers, but the goal was accomplished. We passed by reference. Does it make sense? All right, how would code change if we return int star like that? All right, so let's actually, see what will happen. And you can see that, well, for one, it fails to compile, okay, because there is a mismatch between what we promise to return and what we actually return. This is an integer. The type of this highlighted part right now is an integer, right? It's not an int star. It's not a pointer. It's an integer because we dereferenced it. So it's an integer times integer. So it's an integer. So we cannot return the integer if we promise that we are going to return a pointer. Okay, does it make sense? So what if you try to do something like that? So what if we multiplied our two integers and then we are attempting to take an address of that and return that address, right? Which would be a pointer. Would that work? Yes, no, no. Okay, why not? Um, yeah, it's returning the address. So it's not the scope. It's the fact that you can only take an address of a variable, not an expression. So you can only take an address of an L value. Here, it's just the value, right? It would be like 26 or something like that. Well, it's squared, so whatever. 25, right? So you cannot take the address of 25. It's just a value that is computed. It's not a variable. X is a variable. Y in main is a variable, but 25 is not a variable. So you cannot take an address of something that is not a variable, right? Because an address is by definition, the address of memory where this variable is stored. Okay, does it make sense? So, and I mean, of course, we could have, we could have, if we had a variable here, right? Then technically can do something like that. So let's give it a shot, and I make change here. Let's see if this works, and it still doesn't work. Why? And here it is scoping, right? Exactly, because we are trying to return an address of the local variable. Local variables are stored on stack. When we exit foo, when we leave foo, that stack is discarded. So this address becomes invalid because it points to the address that is no longer in the stack frame of that function, right? Because that stack frame has been has been destroyed. So if we try to do something like that instead, now it compiles, right? Because now we have a global variable that is accessible, that that exists both when we execute foo and when we execute main. And of course, I mean, we departed from the original intent of the code, so we just playing with the syntax and understanding the scoping and the idea of taking the address of something. Okay, so let me restore this to our original example, just in case. Okay, but Z doesn't have an R value. Would that just return the address of where it is? So ampersand Z returns the address. Okay, Z is a variable, and it was a global variable in our latest example, and therefore we can take that address and return it. What is stored in this address is a completely different question. If we never initialize Z, then the contents is undefined, and we definitely should care about that if we care about the correctness of the program. But you can, syntactically, you can return the address of Z if foo is defined as, returning in star. Yeah, I didn't correct Sublime. I just didn't register it. So yeah, it's fine. It's not against the law. All right. All right. Moving on. So next thing that we need to talk about is twist our rivers slightly so that we allocate their memory, that the exact amount of memory that we need given our actual string s. So we take their len of s, our input string, and allocate their memory for that many characters that s contains. Plus we have to add one for their null terminator. Okay, because when we do strlen, it will only give us the real characters, not counting their null terminator. And that's pretty much it. We no longer need to have this magical number max, and our buffer is just a pointer to a character, so it's we can treat it as a character array, and everything else largely remains the same, except for if we dynamically allocated memory, we have to deallocate or free memory as well. Does buff have to be shorter than s for str copy? So str copy, their destination is here s, the source is here buff, and their whatever you are copying has to fit into your destination. Okay. No, there are no smart pointers. There are also, there are only one flavor of point. There's only one flavor of pointers. That's exactly, that's the flavor of pointers that we're discussing. Aha! Someone asked a really cool question. So, casting, their example in the slides, and let's actually find that example. Yeah, here it uses character star to cast the return value of malloc to match their, the type of buff. Is it necessary to do or not? And see, it is not required. And here's another holy war for you. And you can read like long threads of discussions on Stack Overflow or any C++ related resource about whether people should cast or should not cast. And there are people who support fiercely their point of view. So technically, from the standpoint of their compiler, it is not required. So the return value of malloc is void star, and that can be automatically cast to any pointer type, including character star. So that's why this code that we have here in examples, it totally works. And then there's, like I said, the discussion of whether it's a good idea to cast or not, and the pros and cons. So, short answer is you don't have to if you think it is, if it makes you feel better and if you want your code to be compiled with a C++ compiler, then you should use the cast. If you want to stick to their plain old C way of doing things, you skip this cast. Okay, so you support casting. How would the code know what type you want? Like I said, with a plain old C, void star is automatically considered compatible with any pointer. So as far as the syntax of the language is concerned, it doesn't matter. And plain old C has its old little quirks that might be very surprising to you. So why don't we try this reverse malloc C and make sure that it compiles. Okay, it compiles and runs, as we can see. So what would happen if we put a character star here? Well, like I promised you, it's going to compile and run equally well. So what happens if and now to the interesting stuff. What happens if we comment out stdlib? What do you think is going to happen? And we know that malloc and free are in stdlib. So if we comment out this include for this header file, what is going to happen? One compile, it will show warnings. Okay. It shows warnings for sure, and exit failure is undeclared. So let me replace it with 1. Try again, and it gives me warnings, but it compiles. Okay, what C version should we be using? I would recommend anything starting from NCC and up. So I wouldn't recommend Kernighan and Ricci dialect, but NCC or anything above should be good. Okay, so their good question is this code, did this code compile? And the answer is, well, let's remove our a.out, make sure that there is no compiled code, and then compile it again. And now we see that, oh, there is .out. It definitely compiled. So what happens when I run it? And of course, if I spell it right, it should run, and it appears to be working. And it's like, how is that even possible? If we didn't include the header for for their library that contains the definition of these two functions, where are they coming from? And the answer is, well, actually, C takes their automatically sort of finds those functions in their in the standard library. But then look at this funny thing. We remove this cast that we added before, and we recompile, gives the same warnings, and we run it, and it works again. However, let me actually. Compile it one more time and run it again. So you see, it still works, right? So, but there might be cases. So on other platforms, you might actually get, and depending on their version of the GCC as well, you might get a seg fault. Okay, so just be careful. Be careful with this, right? Because you would think that the code would not compile, but it actually compiles. All right. Yeah, it would be funny to see what is how it works on submidi. Will it still deallocate the memory? Yes, it would. So this whole mess is actually due to the very old Kernighan and Ricci dialect of C, where if you do not define a function, you would come up with sort of default implicit definition of the implicit declaration of the function, and so one of their things is that this definition works like that. Okay, so it has nothing in their parentheses, and by default, it returns an int. So that's like if you do not define a function, it will be assumed to return an int and to take. So here's another difference between C and C++. If you have empty, if you have nothing in the parens, what do you think is going to happen? How parameters of this function are treated? So does it like correspond to no parameters in a function? All right. So let's okay. Let me clarify. All right. So we have our malloc. It compiles and fine. Okay. And now I want to do something fancy. All right. I call f1 with no arguments. Okay. So far so good. It works. What about now? It actually compiles. So, yeah, exactly. What? Exactly. You have every right to say that. The code is morally wrong. Well, no, it's just C. So empty, nothing in the parentheses in C has a different meaning from C++. In C++, it means this function takes no arguments. It has no formal parameters. In C, it means that this function takes any number of any arguments. Okay, so and that's why you can see it totally works if if you pass 25, and see if it would totally work if if you pass just one integer argument. You see it all works. And if you want to specify in C that, that void code doesn't compile, okay, which is probably what I wanted. So in C++, it is recommended to put void in here, right, to make sure that you are then not accidentally call this function with some arguments, thinking that in C it means that empty parenthesis means no arguments, but in fact it allows any arguments, all of them, any combination of them. Yeah, so leaving them empty causes the problem, of course, because then you might be able to call this this program with incorrect arguments from what their function expects. Okay, incorrect types. All right, so let's. Oh, you think it's poll time? Almost. So I want to look at this example, and so hopefully we are good with malloc, and now I wanna do this. This is something very similar to what you've done in the lab. So hopefully we are all good with that. So you can specify with printf the precision and their width and the type of their variable to output. And when we call sqrt, it is actually a function from the math library. So we include math.h here. And empty parentheses capture with arguments. Yes, they do. And so let's printf examples. Printf examples. All right. And it fails to compile. Why? What did I forget? Well, I forgot one thing, that the math library is not part of their standard libc library. So it's a separate M library, math library. And when you attempt to compile the code, note that it actually compiles, but it fails to link. So this LD, you see, this tool LD is a linker, so it's not technically a compiler. So what it means is you promised to their linker that this function exists, and its definition, its header is in this math.h header file, but it actually misses the linker, is unable to find the actual compiled sqrt, right? Their actual code, compiled binary code with this sqrt. So you have to specify additional library that should be included when linking a code, and this is -lm. So M stands for math, -l stands for linker. So you want, when you are linking your code after compiling, so GCC can do both linking and both compiling and linking. So after it compiled, you want the linker to have access to the sqrt implementation from the math library. And we will see, later on, much later in this class, that if you want to, use some other features like, you know, pthreads or MPI or OpenMP, you might also need to link with the corresponding libraries. Otherwise, your code wouldn't compile. So once I specify this -lm, then I am all good with running my code. My code finally works. All right, and I believe this is our poll number 1, and you can start answering. Okay, and in the meantime, we are moving forward. So this is their compilation. We already talked about it, and so we looked at this and C libraries. There are many of them. We will use most of the stuff that is shown in this slide. So printf, scanf, fopen, fread, string manipulation functions, math library, right? sqrt is one of them. So names are pretty much self-explanatory. Where are the polls? The polls are on submittee. If you go to here under submittee polls, hopefully you should be able to see the poll. Yeah, and one of them is open, so you can answer it. Submittee is not working. It's probably slow because we have 200 people who are loading the same page at once. So just give it a few minutes or refresh the page. Okay. And all right. So that's that. Printf we already discussed. So you specify the format string as the first argument, and then the corresponding number of additional arguments that would get matched to those percent something pieces in the format string. So it works for in the simplest form. You can just specify the string that you want to print. It can have non-printable characters like tabulation here, %t is a tab is a tabulation character, and that would be very useful when you format your output for things like matrices, or for things like and you will have to do this a lot, like printing their printing their diagrams of how MIPS code is processed in the pipeline processor. So you definitely gonna need this \t. Okay, and then there are these percent something formatting patterns that are matched with their arguments. So this I is matched with a %d. What is %d? %d, D stands for decimal. So there's a number of those formatting characters supported. Here's a list, and you can also print as hexadecimal. And again, when we get into MIPS, then you will definitely need to print a lot of hexadecimal stuff. So please remember to use this %x. Okay, so even if you have include math, you use sqrt, you need to compile with -m. Yes, as someone already answered. Thank you. What's the poll answer? Well, do not share answers, right? They are. It is your own work. Okay. Okay. So here are their formats, and yeah, you can have all the different sorts of fun with printf. %s is to print the string itself, right? So if s is a C string, a character of an array of characters, you do %s. It prints essentially prints the string. Okay, so here's another example with the width and their number of and the number of digits after their decimal. Again, if you want to do formatting. Is there anything wrong with? Oh, okay. So someone is asking about their correct answer, right? Okay, sure. So we remind me next lecture on Friday to go over it, right? Yeah, we would go over the poll, but the poll is still running. Okay, so we agreed to have it run until the end of the lecture. So that's that kind of doesn't make any sense to go over it now, right? So is it okay if we go over that next week on next lecture on Friday? Yeah, we will go over it eventually. Yeah, sure. Okay, cool. All right. So this is an example of how you can pretty print, format nicely your output by using printf with, and here it's just spaces, but you can also use tabulation. And in many cases, tabulation is preferred because it moves their output insertion point, or out the position of where their next output is going to be produced to the next fourth or eighth or whatever the setting of your console is. So to the next position that is divisible by 4 or by 8. So it allows you to tabulate like you would do with an old typewriter. I'm sure I don't know if any of you have seen a mechanical typewriter, maybe in the museum, but this tabulation goes way back to mechanical typewriters. So 20 is the width, the entire width of the field. Okay, so it's here, right? So it is their entire width of the field. So if their output is less than 20 characters, then it will be padded with something. And that something is different depending on the type of the value that you are printing. It can be for for numbers, by default, it's a space. So here we have, a few additional spaces so that altogether this output is 20 characters. And you can actually ask it to be leading zeros. So if you want our leading zeros instead of instead of spaces, you can put a 0 in your format string, and you can have those leading zeros. Point 15 is their number of decimals after in the output. F stands for float. I'm actually wrong. F stands for fixed point. All right, it's the same for float and double. So it's the fixed precision decimal number. Okay, so yeah, all different sorts of things you can do with printf. If you are want to look up their official manual, man3 printf will give you. So 0.15 is the number of decimals and 20 is the number of spaces. No, 20 is the total number, is the total size of the field, right? So you have 20 characters where you dump your output, and 15 of those would be their digits to the right of the decimal point, and then dot is 1 point, and then in our example 3 was another, and it's less than 20 altogether, right? It's 15, 16, 17, so there will be 3 additional spaces to the left of the 3, right? Because you requested the output to occupy exactly 20 characters. So if it's fewer, then it will be padded with by default with spaces. If it's greater than 20, it will go over 20. No, it will not. It will not cut off some numbers. It will just go over 20. Okay, so. All right, and so scanf is, in a sense, opposite to printf. So it allows you to get input from the user from their standard input. It's as much as fun as printf is. The only scary thing is that you need to use pointers, because whatever input your user provided, you need to store this input in your variables. So you have to give scanf an address of the variable where you want the input to be stored. So, yeah, you don't really need pointers. You need addresses, but it's just the technicality, right? So you have to give scanf an address. So you can use pointers, of course, and that's what we are going to use. So scanf supports the same formatting string as printf, and then you have to specify the addresses. So like in this example, you expect the user to enter 2 integers, 2 decimal whole numbers, and you will store the first one in a variable x and the second one in variable y. You need to take addresses of x and y before you give them to scanf, because otherwise scanf would not be able to write to those variables, right? If you don't give their address, if you don't give the pointer, it would not be able to modify those values. That goes back to our example with pass by reference. We want x and y to be passed by reference when we give those arguments to scanf, so that scanf could actually modify the values in those variables. Does it separate strings by spaces? Yes. So scanf assumes that there is here you see there's a space. You can make it anything you want. All right. So here is an example with taking floating or fixed precision number as an input. And then computing the square root. So the good thing is it automatically converts the value that their user entered as as characters or strings. It converts those characters to the appropriate data type, float in this example. And of course, it totally works with strings as well. And as before, you can do man3 scanf to you know, read all the details. And you will need to. So I just don't want to waste our time, doing this in class. Hopefully, it's pretty straightforward. But like I said, if I say something straightforward and it's totally not straightforward to you, please ask me a question and tell me to go back and expand. Okay. Can we use int star x and then scanf percent d x? Yes, totally, because x would be the pointer, it would be the address. You need to make sure that you initialize this x with something, right? So if you do not initialize x, it's going to contain garbage. So you would have to do something x equals percent ampersand y, so that you so that you initialize this x with an address of some real variable. Man page is just the way you can request help about any C functions if you're running any kind of Unix or Linux. So it gives you their documentation for for any functions that we are discussing. And of course, you can just another option is you can just Google it. All right, so we have 3 minutes left. So I'm going to open the second poll, although we didn't quite reach it, but I want to. Yeah, it's here on slide 47. Okay, so this is our pop quiz number 2, and so make sure you select the correct answer. All right, so it's all or nothing. You either earn an A if it is correct, or you earn an F if you didn't get their answer correct. Yeah, this is a trick question. Exactly. Given that there's only one correct answer, one and only one, you have to, pick the right side. Okay. So reading a line. Why do we need a special? Well, VS Code is Visual Studio Code, so it's there. Vim and VI, yeah, we kind of bulk them together. Excel as an editor. Well, that's interesting. Sublime for Prof. Yeah, I'm actually not that big fan of Sublime, to tell you the truth. So, okay, yeah. All right, 1 minute left. So let's see what we can cover in the time remaining. So let's at least cover their F gets. So this is what you use if you need to read the entire line of output of input, right? So the entire string, the entire set of characters that the user entered, and when they press enter, you want to capture this all, because if you do, if you use scanf with with a string that contains spaces, it will treat spaces as separators, and it will give you one word at a time. So if you want to get the whole line of input, you need to use fgets, and fgets supports reading from arbitrary files. So if you want to read from their terminal, you specify stdin. If you want to read from any other file, you specify their file handler here, the file handle here as their last argument to fgets. And other I/O stuff, it's pretty self-explanatory. So this one, I leave it for you to take a look. So fopen and fclose, that's what you use to open and close the file. Scanf, printf, gets is something that, so fgets we discussed. Printf, fprintf, fscanf is something that we use to, as scanf and printf, just from a file, not from standard in. And fread and fwrite, this is what you use to read and write the file. So let's, and string functions, we already store them. String copy string, cstring from source to destination. Strlen is to get the length of the string. Strtalk is to get tokens from a string, to tokenize strings, and it can be very handy if if you're doing any kind of parsing of the string, but you're not going to need it for other for the exam. All right. Hopefully back to this editor question. Hopefully you all understand that I was kidding about one correct answer. So this is actually the survey type of question where any answer would be considered correct. All right. 151. We are 1 minute over our time. I apologize for that. Let's stop here, and thank you very much for attending. Good luck on their exam. Please ask plenty of questions to your lab TAs, thank you for attending this lecture. I will see you on Friday, and you folks have a great Labor Day weekend. Try to enjoy yourself while it is still warm and hopefully sunny. Take care.